So then let me give a short introduction to the asynchronous concept of writing programs. Usually, when you write a simple script in Python, it starts somewhere and then it goes on until the end in one thread, in one process. And every time it has to calculate something, to do some CPU-bounded task, it will just work on it. And as soon as it has to do something with the network, communicate with the database, web services, reading, writing something over network, it will just wait. And then it is clear that in my program I am at the point where I am going to send some query to the database, for example PostgreSQL, and when the answer comes, I can go on. And in between, my program is just waiting on the network. If I want to save some time, because I have my CPU that is just idle and doesn't have to do anything, I could parallelize the things. For example, while I'm waiting for the answer from the database, I could calculate something, or I could send 2 or more queries to the database, or download something from the web and communicate with the database, and everything at the same time, because my CPU has one core and it has nothing to do while it is waiting for an answer. So I could divide my process into several processes or start several threads. But the problem with this concept is that it is not you who decide what is going on. It's the system, it's the operating system that is going to decide what part of your code it is going to execute at the same moment. And in that case, you will have a real problem with accessing common variables. If we have some variable that is accessed from several processes, you cannot access it directly because one is writing this variable, the other one wants to read it, the third one is going to write maybe at the same moment or not, and your code will be unpredictable. The operations in your code will be just unpredictable, and you are not going to know safely which part of your code is accessing which variable. There are some objects or some ways of communicating between projects, between processes, using signals, using semaphores, using queues. But this may be quite complicated and with quite a lot of overhead. In Python 3 and in some other languages, it is possible to do asynchronous code. Writing asynchronous code means that in your code you start several so-called coroutines, and these coroutines, they run one at the same time. So at one moment I say I'm now starting 2 coroutines, and these coroutines are going to run completely until a point where you say that you are giving away the control. So giving away a control is, for example, I'm preparing my database query, putting the string together. It is a very CPU-intensive task. And then I'm going to send my query to the database, and then it may take 1 millisecond or 1 minute until an answer comes back. And at that time, I'm just giving the control back to the main process that is going to take care of all my coroutines, and that is going to distribute the CPU time to the coroutines and decide which one is going to run now. Advantage of this code is that you write a straight Python code and you define exactly where you want to give the control back to the main process, to this main loop that is going to take care of your coroutines. And all the rest will run consistently together as one block of code. This means that at any time you can access some common variables, and you don't have to expect that someone else is going to access these variables at the same time. Now we are going to write a very simple code without PostgreSQL, where I'm going to show you how to write asynchronous code. So I promised to use light background and larger text. Is it large enough? Can you read it? Yeah, okay. I have Python 3.7 standard. And now I have to import asyncpg. It's in the standard Python 3 library. Okay, this is the simplest code that could possibly work. So okay, this works. So, as I told you, there is one central loop, event loop, that is going to take care of our asynchronous coroutines. And this loop is available as getEvent loop. So this is everything. I define one loop, and then I say this coroutine named run that I'm going to define now has to run until it is completed. And now my method run is quite simple, but this is a method. I need it to be a coroutine. Everything I have to do is to put an async before def. It's done. So what it does, my main process in this loop starts one coroutine and waits until it is done. The coroutine starts, prints hello world, it is done, and my program is done. Finished. Now let's say that we want to do some CPU-intensive task. We are going to sleep a little bit. Sleeping is also very intensive. I import time. I sleep for a second. And then I print world. Okay, so this, when I start it, hello, 1 second, and world appears. Okay, that's all. Let's do another coroutine to see some action. I start another coroutine that is called monitor. That runs the whole time, that prints monitor, and that sleeps for 0.1 seconds. Okay, now I ignore this run, I use this monitor, start this monitor, and then 10 times per second it writes monitor. But we want to run these two coroutines at the same time. So what I have to do is gather these two coroutines. So asyncpg gather accepts a number or any number of coroutines. It starts them at the same time and waits until all of them are finished. So now I start it, and there is hello, world, and then monitor the whole time. Which means he starts this coroutine, prints hello, waits 1 second, prints world, then it is finished, and then he can give the control to the monitor. But you see that this monitor started only after run was finished. And this is because we bounded the CPU for us for the whole time. Print is CPU, time sleep is as well CPU because we didn't give away the control, and print world is as well CPU. And here the same. So actually our coroutines will run and then monitor after it. But maybe we could make them run at the same time. So what we have to do is really sleep, but return the control. And in that case, we say await async IO sleep. It is the same like time sleep. It sleeps for 1 second between hello and world, but it returns the control. And if we do the same here, await async IO sleep, then, so you see, hello, 10 times monitor, and then world. It means both coroutines started at the same time, hello printed the first line, then waited for 1 whole second until it expected the control again, and monitor in between managed to print itself 10 times and then return the control to world, and again. Is that clear? Do you understand how that could happen? Because this is magic. So, now you see that we can write normal Python code, and only we have to put some await from time to time. So, for example, I can do something even more intensive. While true, I sleep for some random time. Import random. Okay, so now I have 2 very similar coroutines. Both of them work or run indefinitely. Every time they print a line, and then they sleep for something between 0 and 1 second randomly. Now when I start this, what was wrong? Monitor and run. Okay, now I didn't save it before. So you see now we have 2 coroutines that run at the same time, and they sleep most of the time, but from time to time they return the control. Where could we use this? We could, for example, communicate with the database. So let's keep this monitor that is going to type the current state 10 times a second. And in our run, we can connect to the database. We import asyncpg. That's a library for communication with psychopg. Again, no part of the standard library because it gets a lot of development and there are new versions quite often. Fast PostgreSQL database client library for Python async IO. Actually, there is a whole ecosystem of asynchronous Python libraries for all sorts of databases, web protocols that you can use. Documentation can be found here. So we have our asyncpg. And now let's connect. So in the run, I will connect to the database. And if we want to connect to the database, we have to await. And every time you see in your code some await, it is the place where we do something with the network or with sleep. And we return the control to the main loop and then await, and will be awakened, and we can go on as soon as the information comes back. Sorry. Who did arrive now 17 minutes ago, who wasn't here at the first workshop? Nobody. Okay, so I'm using the same table, the same connection as before. And now with this connection fetch, I can just define my query that I want to get from the database. And I print my rows. So let's see whether this works. No module name. Okay, sorry. I have to start my virtual environment. Okay, so this works. So my coroutine monitor started, and then here I received my list of records. So let's do it a little bit more readable. Okay, so now here. Communicating with the database took a little bit time, so the first coroutine had enough time to print monitor ones. Then we received our rows. We are going to have a look at these rows afterwards. And our second coroutine monitor just kept writing its lines always after 1 second. If we want to have a look at these records interactively, it means in IPython, it is a good idea to use the most recent version of IPython that contains already the whole asynchronous stuff. In our code, you see that here I have to use loop, async.io get event loop, and then async.io gather, run, monitor, and define it define everything with the loop. But in IPython, I can start, or I can work with this information directly without defining the loop. But this works only in the most recent versions of IPython. So we have here IPython. I define my connection string, and then I can tell that my connection is asyncpg connect with await, and I have my connection. This is the information about my connection with a question mark in IPython, representation of a database session. And now, rows equals await, connection, fetch, select star from person. Now let's take the first row. In Python, the arrays start with 0. It is asyncpg record. And now I can ask for those fields. Yeah. Okay. Any questions? The next thing that is very important is the SQL injection prevention. So now we are going to see how to ask for some data from the database if we give a variable. This is a little bit different from psycopg2. So if I say that I want a record from the database where ID equals 2, okay, this works. And I want to get it as a variable, I have to use $sign. And then, not a tuple, but directly give the number, give all the variables that I need. So for example, with a 2, I get the information. I have to tell that I prefer this % and parenthesis system from psycopg2. Okay. So this is how this looks like. With the context managers, with this with and connection, you can do it in Python 3 in this asynchronous Python as well. You do async with. So with asynchronous with asyncpg connect, I get this connection, and this connection is available in this block. And as soon as the indentation ends, the connection will be closed. Async with usually. Transactions. Oh, no, okay, sorry, it was for the transactions. So if you want to do a transaction, async with connection transaction, sorry. So, async with connection transaction. So, this is how you do transaction. So I have a connection, and then with this transaction, with asynchronous with connection transaction, as soon as it exits this block, the transaction will be committed or rollback, depending on whether there is an exception or not. If we, of course, in select, you don't have a transaction, but if you have some insert or update or delete. Usually with asynchronous code, you don't know how many connections you need at the same time. If you have a web service, then it makes sense to start with a pool of connections. So at the same time, you open automatically 10 connections, and if the coroutines need the connection, they will just wait until there is a free connection, available connection in this pool, and then they are going to take it. So let's write a short web service that will allow us to connect to the database with several connections, and then at the same time we can access it through the web interface and access the data from the database. I prepared already here. Yeah. Yeah. Okay, let me explain this code. Actually, what it does is it listens on this port, writes hello every second. We are going to check the code now. And when I do localhost 8080, it will just print 2 to the power of any number. Default is 10. So for example, if I write here 4, it will write 2 to the power of 4 using the database. So import async.io, you know already. Import asyncpg, you know already. And from IO HTTP, import web. IO HTTP is a library sorry, for server and client HTTP connections in asynchronous mode. Now, when we start this, we get a loop. And then we let this init app run, or we initiate it. We'll check it now. And then we can also add some background tasks and some tasks that have to be cleaned up at the end. And then we start it. It is a little bit more complicated version of this loop that we have seen before, but it is actually IO HTTP that is taking care of the whole coroutines. Init app is here. We start the web application. We create a database pool. So this await asyncpg create pool DSN connects to the database. I think the default is 10 connections, and saves it in a pool. A pool is then an asynchronous list of database connections. And then we define that if we call this web service with slash and then some number, it will be saved into the variable power, and we want to run the method handle that we will check right now. Another way is that if you don't give any number in the web interface, it will run handle as well. And then you see this handle, and this handle is a coroutine that will run every time we ask it. We ask for it in our browser. So the handle gets a request. This request has an app, this web application as attribute, and this app pool is actually the pool that we started here. And then from this request, we can match this information that is defined here, and we ask for the variable power. If it is not present, then it will return number 10 as a default. So this is power. And this part is interesting. In async, we wait until the pool returns us a connection. So now imagine that there is a lot of traffic. We have just, in our pool, we have just 10 connections. There is a lot of traffic, and suddenly 20, 30, 50 handles are started. Every one of them will wait at this point until pool returns them one available connection. And as you see, this is a context manager. As soon as it exits this part, this indented block, it will return this connection back to the pool. So even this, if this handle coroutine is started 100 times, this block may run only in 10 instances of this coroutine. And then within this connection, we start a transaction. Connection fetch, you know it already, fetch val returns just one value. And then we ask the database for select 2 to the power of this number, return results, and our result that we return to the web browser is a text. 2 to the power of your variable power is equal this result that comes from the database. So you see this is what the database returns. And now, if we want to wait a little bit, wait async IO sleep 1 second. Now tell me why it returns immediately. Oops. Oh, that's a good question. Okay. Okay, and our monitor runs in the background because we start, so here in app on startup, we appended the coroutine start background tasks. So to our monitor, we just edit a new task, this monitor app that runs infinitely, prints hello, and sleeps for 1 second. If we want to stop this program, it keeps writing hello every second. We can press Ctrl+C. And in that case, this app will check its own cleanup methods that are defined here. And in these cleanup background tasks, it will cancel the task monitor. Canceling a task means that this coroutine receives a cancelled error exception. And here in monitor, we expect that cancelled error exception comes. And as soon as in this block this exception happens, it is going to jump to here to accept async IO cancelled error and print O. So now I do Ctrl+C. Stop hello. And O. And when we were talking here about the sleeping, nobody told me that I have to restart my application, because actually this was the problem. So now we are going to do it again. We start it. Every second it prints hello. And in our browser, you see it took 1 second. And after 1 second, it gave me the result. Oops. Yep. Okay. Any questions? Yep. Postgres log. In my database, Postgres log.
Yes, in your Postgres database.
Okay. Now tell me where it is located. I am now on my Docker instance.
Var log.
In var log. Postgres. PostgreSQL. But there is nothing. No. You see, there is nothing. There is no file. Huh? Anyone has an idea where to find the Postgres log in Docker? Docker logs, but it's writing into a file. You can try Docker logs. Docker logs, not help. Okay, here are they. So we are UTC. No, there nothing came. This is 13:18 UTC. This is Central European time. So no, we have nothing in the log. More verbose, maybe? Details? No. There is no, the last log is 20 minutes ago, so 30 minutes, 20. But well, this should be our logs, yeah. Yes, but these are statement selects. No. Okay, so what are you looking for? No. Okay, so this is how asynchronous Python works. So actually, even if you have a coroutine, even within a coroutine, you can start other coroutines and then wait until the first of them or all of them are finished, or until the first of them raises an exception. Even before async.io, there was a possibility of some asynchronous code, mostly using twisted, but that was used mostly by defining callbacks, which wasn't so nice to read. Okay. Okay, so what else should we try out with asyncpg? We have seen the SQL injection prevention, the pools. And with using IPython, you can discover all the methods that are available. There was a question before about copy to, copy from. They are available here as well. Actually, what is interesting in PostgreSQL or in asynchronous Python, that you can use this listen and notify, because your coroutine can just wait until some notify event comes in the database. Okay, so what should we try next? Any ideas where you could use these asynchronous features in Python? Is anybody still using Python 2, actually? But you are going to switch this year. Another interesting topic would be Python in PostgreSQL. But it's not for today. Okay, so if there are no more questions, no practical tips. Yeah?
Hello. Is asyncpg production ready?
Yeah.
Thank you.
I'm using it in production, yeah. Even on the website of asyncpg, you see this word fast. And they write it is really fast. In our testing, asyncpg is on average 3 times faster than psychopg2. But of course, the development is going on, and the features are changing from time to time. So if you are using in production, it's a very good idea to stay with one version and then test it for the future ones. No more questions? Yeah?
About Python in PostgreSQL.
Is the microphone on?
Is it a... Раз, два. What about performance of Python?
What about?
Performance of Python in the PostgreSQL. Is it fast enough in compare with PL?
Python in PostgreSQL?
Yes.
Yes, it's the topic that people ask me. I don't have much experience with that. It's about writing functions in PostgreSQL using Python. You mean that?
Yes, and it is stable and fast enough.
I don't usually write Python functions in PostgreSQL. People are using it. It could be an interesting topic to discuss, but I have little experience with that. So I don't know.
Okay, thanks.
But of course, Python from outside of PostgreSQL communicating with PostgreSQL, it's the best, very good choice because you write very little code in Python to do a lot of stuff. And your database connection is probably slower than the Python code that you are using to access it. So Python is really okay for most tasks. Any more questions? Ideas? You're just waiting to get out and type your code in Python? Try it out. In that case, thank you very much.